Okay, so today I'm going to show you a little bit more about setting up more advanced material setups and components in Aframe-VR using Three.js, GLTFs, things like that. But first I want to go over what I've done previously using the just the standard Aframe editor in the previous video. So I'm just going to open this with Firefox. So again, to cover what I talked about in the previous video, I'm serving this locally in Firefox because I've set Firefox up to ignore the cores kind of file, the local file setup. I've disabled that in this browser because I don't use this browser for anything else. Another way to do that, if you go and look on the web for, let's do like local development Aframe-VR, the first thing that'll come up is this page, and then it'll come into local development, and they talk about downloading Mongoose if you want to make a local server. What I've done is I've gone and set up a little Python bat file so that I can basically just run from my directory. You just have to swap into the directory. Let me open up the bat here and show you. So you basically just cd into the directory that you're running your A-frames from, start a Python server, and then I've got it so it opens up Chrome and sets up a local host. So if I just double click on that, it's going to come up to the directory. I can click on the example that I just loaded in Firefox, and now I've got it running locally in Chrome. All right, so let's talk about what I did the last time. I set up this using the A-frame inspector, Control-Alt-I. I set up the PBR texture for this, just using standard and loading it with the A assets here. So I'm loading this door color map, door normal map, metallic, and roughness map. And then applying that to this object. And right now I'm setting it up, let's see. Yeah, I don't have the spherical environment map, but if I wanted to apply that, notice that the top of this, the top of this sphere is kind of dark. And that's because there's no environment map showing up in it. It's just reflecting black. The other thing is, if you look at the sphere, this sphere that I've got set up, I'm loading that spherical environment map sky. The problem with that is that there's a bug in Three.js and A-frame that the spherical environment map basically follows the camera around. So what you want to use if you want to get like an accurate environment map is this environment map node here. And in order to do that, you have to set up a cube map. So if you want to make a cube map, if you do equirectangular to cube map as a search in Google, you're going to come across a couple of converters. This one I found works pretty well, this 360 toolkit. And basically you can load your equirectangular image and then select this one because you're going to want separate image files, and export these to your directory. So if we look at what that looks like here, if we go into textures, environments, we've got 6 different sides of the cube. So a negative x, negative y, and a negative z, positive z. And those then you can load, let me open up a different, you can load those as a separate cube map. So if I open up, let's see if I've got it still loaded in this, in my assets. Oh no, that's JavaScript. Yeah, so if you look at this cube map ID Sky1, if I just copied this and then paste it into my blank here in the A Assets tab, You want to load these in a specific order. So it would be pos x, negative x, positive y, negative y. Negative z, positive z is probably wrong. They should be in the same order, so it's probably going to be positive z, negative z. Basically, it's the setup should be right, left, up, down, forward, backward in terms of the order that you load the images. We'll save that, and then going back to my Chrome, I could just reload this. Control-Alt-I. So now, if I select this gold sphere, let me zoom in on that. I'm going to turn off the spherical environment map, and I want to just hit this sky 1, which is the ID that I gave right here to the cube map. So it would be for the environment map right here, pound sky 1. And then if I go back to scene and inspect the scene, so notice it doesn't update for some reason. That's the, oh wait, let me go into my code. For some reason, something the way I'm doing this, let's look up CubeMap in Aframe, or CubeMap 3J. Yeah, CubeMap Aframe VR. Sorry, not CubeMap. And then, so there's Aframe CubeMap component. What is that? It's going to go into, it's going to load a cube map for the sky. Bunch of complaints. Let me do Docks. Not having a whole lot of luck here, so let's go to Aframe-VR. And we'll go to the Docks and look at, excuse me, material. We'll find it this way, right here. And then you're going to look in the material, there'll be the environment map. And then we've got A assets, A cube map. Let me see if I'm setting that up right in my code. Yeah. Image source / textures environments. Let me make sure that's right. Textures environments. JPEG. All that's right. Let me make sure I'm closing. So we may want to set this, but I've just noticed that this doesn't seem to load correctly. So the ID equals sky1 cube map. So let's go into sorry. Let's go into our cube or our sphere. The gold sphere right here. And for, instead of spherical environment map, just change this to lowercase e or env map, env map. And we'll change that to sky1 and save it. Oops. Cancel. Save that and go to our server for our hello world here and reload. So again, it's going to come up dark, but then it loads this. Now, notice, oh wait, it's still doing the environment map. Let me look at that and make sure. I may have loaded the wrong one. Gold sphere. Spherical environment map's not loaded. Environment map is set to sky 1, so it should. Let's make sure. Oops. Yeah, okay, it's behaving much better now. So now it behaves much more like an environment map. Okay, see how it sort of shifts around the sphere instead of following the camera like it was. Plus, if we take this roughness amount, we can blur it. Notice that the map itself gets kind of blurred, and it kind of mimics a metallic reflection much more, like a rough kind of brushed aluminum or brushed metal metallic. So that's how an environment map can get applied as a cube map. But now, if you'll notice, after all that work, that there's no, this plane, this cube, this sphere, nothing's getting reflected in this environment map. So really what we want is the ability to capture the environment and render a cube map and slap that into the environment of this object, the environment map, at the beginning of the scene. So I've created a component to do that. And the way that works is, if you look, go back out. This component, I've called it, well, let's go and show it on the ThreeJs Docks first. So the point of this video is to show you that ThreeJS has a lot more stuff that you can do, pretty advanced stuff with WebGL that Aframe just doesn't expose. It's in there, you have to activate it, but it's all built in there because Aframe uses ThreeJS. So in ThreeJS, you can use this cube camera. If we go to this example, and this is just in the ThreeJS Docks, you'll see that they're rendering animated environment maps on the fly here and applying and injecting that into the actual environment map for this object, which is pretty cool. So if we go back and look at how they do that, it's with the cube camera. So a cube camera is just a ThreeJS camera. It's called a cube camera. It takes a near clipping plane, a far clipping plane, and then the actual resolution of the output images that you'll want to use. So this will be 128 pixels per face. And then you can take that cube camera and inject the environment map using the cube camera render target here. So it says environment map cube camera render target. So what I've gone and done is created a component that'll do that in Aframe. So if we look at the CubeCamEnvironment.js, and I'm going to put a link to this from the GitHub in the description for this video. If we take a look at that and create a resolution, this is how you create or inject ThreeJS type behavior into Aframe. We've created a component called camera-cube-environment. And for that we need a schema. We have the resolution, the distance, which will be the far clipping plane, and then I've got this interval in this repeat function that allows us to turn the animation, whether or not it's going to actually record the animation in real time, which will lead up to the frame. We'll show you that in a sec. So then I just create the new cube camera just like ThreeJS here in the init function. I'm doing this because if you don't set a MIP, if you don't set the render target texture min filter to equal some sort of MIP map, the behavior I showed you where you can set the roughness of the material and it'll actually blur the material, it won't work. You'll just get this sharp reflection all the time. So this is kind of critical. This cam render target text min filter equals 3 linear MIP map linear filter is critical for being able to have PBR material that'll take the environment map and this real-time environment map and actually blur it. And then I just take and add the camera to the object for this that I'm applying this component to, and in the end I just parse through or traverse through that object, and at the very end set the environment map for its material to this render target texture and tell it that it needs to be updated. So when we take that and apply it to our sphere here, so instead of doing the environment map in the material, I'm going to leave it blank. We'll save that. We'll go back and show you what that does to the hello world. So now we're going to lose our environment map because we're not going to have an environment map at all, right, on the sphere. There's no environment map, but I've got the reflection and the diffuse or the roughness set up. I can, let me make sure I've got this. I'm loading. That's the other thing is, like, I've created this component. To use the component in your scene, you have to make sure you load that script. So I'm loading it here, and then put it. So I've got it already set up on this other sphere. So I'm going to just show you. I'm going to copy this setup. And you just put it as a new attribute on your gold sphere here in the tag. So what we have is camera-cube-environment, which is the name of the component. I'm setting the distance to 100,000. I could probably make that just 50,000. Resolution, in this case I'm going to set it to 256 pixels per face, and I've got the repeat turned off with false, and this interval is just how long it'll take for it to calculate the first render. Save that, go back and refresh. Notice that it takes a second to pop it on, but now I've actually got it's capturing the entire scene. The sphere here, the floor, the cube, okay? So now, and it's only capturing that in the very first frame of the first time it's loading the scene. It's going to capture this and apply it, so it's not going to like have a major impact on your frames per second. So we'll get a kind of base for that. If you can check the stats if you select the A scene in the editor, and then under component, just add this stats component, and then go back to your scene. You'll see a frames per second counter up at the top. So it's at 33.9. It's actually probably closer to 40. It's because I'm recording this video. But you'll notice it's not dropping or anything. It's not varying based on the capturing this image, okay? So now what if I want to have, say, let's animate this cube. I've already got this saved as with an animation in this cube map here. Let's go to that. I'm just going to save the, I thought I did. Let me check it. And this one probably. Hit it with Notepad. Yeah, so I've got this animation tag here. I'm not going to show you how to do that, but basically I'm just creating a spinning animation. I'm going to copy and put that into the cube in this blank. You just put that in between the tags here. So I'm adding an animation component that's going to rotate the cube. We'll save that and check it out. Just reload. So now our cube rotates. Okay, so this points out the issue of, okay, I've gone into the trouble of capturing this cube map for the environment, but it's not actually showing the animation of objects or the movement of objects in the scene. How do I fix that? So if I hit Control-I in the component, we'll select our gold sphere, zoom in on it. In the component for this camera cube map right here that's now attached, I've got this repeat checkbox. So if you turn that on, it's going to reset to black, but when you come back to the scene and load, now it's going to capture the animation. Notice that it's capturing it at the 256, so it's relatively pixelated. It's low res, but that's okay. Let me just set that to something like, let's do it lower, so that just to show you how you can optimize this. So if we set it to 32 pixels for each frame, it's going to be super low res now in terms of the reflection. But that may be all you need. I mean, you might have this roughness cranked up. Let's see, yeah, right here, like the 0.4 or something like that. And you're not going to be able to see the reflection map. Actually, let me take it down a notch. Depending on the, and this will show you the interplay of the texture map and the roughness. So you're not seeing the animation anymore. I'm rendering it so we're not getting it, and that's because, well, like I said before, there's a mipmap, mipmaps that are going on when we're capturing this image that's allowing this roughness setup to blur the image. Those mipmaps are lower res maps than the actual texture that we're capturing itself. So when I set this to 32 pixels, the mipmaps are probably just a couple of pixels, so they're going to be super blurry when I blur this thing. So to do it better, we can go back to 256 and go back to our scene. When it captures, now you see we actually get this blurred cube. That's because we actually have the resolution to do it. Before, I was blurring the heck out of probably a 16 or 2 pixel or 4 pixel size image, and it was blurring it and making the whole thing that color. So that kind of shows you how this relationship in terms of blur and the quality of the actual image that you're capturing will affect the final roughness of the object when it's played. Okay, so one more thing to show with this while I've got the repeat turned on is if I turn on this A scene and set the stats, I'm going to show you how bad the hit is to your frames per second. So if I did this without, so we're basically at 22.29 frames per second, where we were at 39 before. Okay, if I've got it on this other sphere, and this is incremental, so if I turn it on for this, now it's at 18 frames per second, 17 frames per second. You don't really need it for this. You can't even see the animation because of the roughness of the detail, and I'm losing frames because of it. So, you know, unless you've got like a mirror or something that you want to be able to show this animation on, and if you do, if it's just a mirror, then you may not even you might want to go and rework this component so that it's not using the standard material, because you can apply just some other less intense material to deal with and get the same kind of reflection and behavior with the component. So I'm going to turn off the repeat for this one. Let's go ahead and take the roughness back. Wait for this one. The 0. So now we should have like a super sharp. So I'm running at like 512 on the cube. It's still not anti-aliased a lot, but it's better than it would be otherwise. And it, you know, it behaves more like a reflection map, kind of. I mean, it's rough, but you get a better impression of what the scene might be like. Okay, and you're capturing this relative to the object position. So if I move this over here, and this one here, something like that, make the cube bigger, move it up, and then rotate it maybe. And go back to the scene. It's capturing well, the rotation got offset because of the way I was my animation was setting it. But you notice that these cube maps are captured relative to each object that I apply them to. If I want to put one on the cube, which I can, be CameraCubeEnvironment, set it to 128, and I'm going to leave the repeat off. Oh wait, I got to turn on. So this, notice that I didn't see anything. That's because I don't have metal or the roughness cranked up. So in order to actually see the environment map, you've got to crank up the metalness, or the roughness needs to be down to something smooth. Oops. So I did apply CameraCube resolution. Should work. Let me think. What could be going on? Do I have a reflection map? Nope. My environment map. It's not set. Shadow. Take the metalness down a notch and see if I get a reflection. So the thing is cubes are going to be harder to see a reflection on. Actually, let me go ahead and do this, because it may be that because I'm adding that. So I'm just going to take my sphere, camera cube here, see, find my box. Yep, right here. Put that. Okay. Save the material. Then I'm going to also want, let's just make it really metallic. So we'll take the metalness and roughness here and put that here. Save that. And reload. So now there's our cube, and you can see it's reflecting the environment, right? Sort of. I mean, it's different. But you'll also notice that it's not capturing this reflected environment right off the top from the sphere. Because you see the darkness, and the same thing in the sphere's environment map. So that's where you have to have that repeat turned on so that it captures each one separately. So if we do F on that to center and set repeat, and the same thing here, notice that now we're getting everything updated. It's probably going to be really low on the frame rate, but we are getting real-time updates. So there's optimizations that could occur that could make this less intensive in terms of the frame rate, where we could just say, when we do this, run it twice. If we don't want to do the repeat for animation, we just want to capture it twice so that we get the renderings of each, or we run it for the number of times it's applied in the scene. We could apply that to this and just check it. We could run it for a few cycles so that you get them. We could also set it so that instead of capturing these maps from 6 different faces in this camera every frame and then resetting it on the same camera, we could do what's called a ping pong, where we have 2 camera cubes and we just alternate using each one, and then as we change it to each one, we update the other so that it puts a little less stress in terms of having to adjust or take a render call and then blank the object and then render it to the same object again. So you can get faster performance that way. The other thing is we could put a pause or create like some sort of throttle so that we're not doing it every frame, which will make it a little bit choppier but might increase performance, so we're not capturing these cubes every frame. So anyway, that's setting up environment reflection. So why go with this inject a cube map from the location versus just loading up a cube environment in the object, right, using whatever section? Because why do we need this? I mean, for one thing, we're getting more accuracy here, but why do we really care about doing this in the first place? It happens that, I have access to these when I apply this material node to any of the primitives in A-frame. I have access to all of these nodes, not all the nodes that you would get with Three.js, but all the nodes that they've exposed using components for A-frame, including the environment map here. The problem is that if I apply something like a GLTF or an OBJ with an MTL or FBX, I load an actual model, which is what, let me show you here. Close this and stop my server. We'll run the bat again and just load it from something else. So if I run cubecam, notice now when I load this model, this GLTF model from that I modeled in Maya and painted these PBR textures in Substance Painter. This is the way a GLTF will load unless you inject an environment map onto it. So if I look at these, I've got 2 GLTF models loaded. This model is the way it loads by default, and again it's dark. And notice I don't have a material node here. I can't access this material node. I can't access the materials because these are like multiple objects in a group, each one having different texture maps. So there's multiple materials on the object, and I don't have any ability to inject or to apply an environment map to it so that it actually renders correctly. If I apply a material node to this, I still won't have control because it doesn't work like that. Once you have a material, see, nothing changed. Once you have a material in this GLTF format, it only uses that material. And you have to drill down into the object, parse through the mesh, in order to be able to make changes to that material. So that's why I made this component, this camera component, which will render. So if you take, go back to our CameraCubeEnvironment, if we put that on there and just leave it at that and then run it, it's going to go and update and capture all of the environment maps and inject them into this GLTF model for each location for the actual object, okay? Which will make it look a lot more realistic. So like in this case, this statue should be in a Greek temple with columns all around. By doing the real-time environment injection, I'll be able to get those columns reflected in this rough gold surface that she has. And if there's anything smooth, it'll show them as well. So you get a much more realistic rendering that way. Let's see, what else? So one other thing I wanted to show, now that we're talking about GLTFs, is, like I said, you can't, there's not a whole lot. When you make these or you get these GLTF files, you don't really get the ability to edit them or see how they're made or see anything about them. And you have to go and create these components that will parse through all of the models and look for specific types of objects in order to manipulate them. A way that you can check them out using this same sort of A-frame inspector method is that Three.js has its own editor. So if you just Google Three.js editor, the first thing that comes up will pop open. If you open it, you'll actually get an editor similar to what you get in A-frame inspector, except it's in some ways it's a little more powerful. So we can load. Let me go ahead and close this hello world so that I'm not rendering that. So we'll load import, and I will go out to my objects. Now the question is, which one do I want to load? Probably actually I loaded it from a different file, but this will actually point out something that I wanted to show anyway. So I'm going to load this GLB, which in this case is the compressed version of a GLTF that I saved. So we'll load that. It's going to take a second to load it. Here she is. When I first come into this, let me do F to zoom in on it. Or actually, I'll just scale her up. Notice she's really dark. That's because there's no lights on her. So I need to add a directional light in this case. Okay. So there she is, the directional light. Notice that she comes in just like an A-frame. She comes in dark. But when I select elements on her, I can actually select the objects here. I actually see all of the contents that make her that make up the shape. Okay. On top of that, I can see the materials too. So if I go through and select the objects, this is the shield. If I look at the material, or actually that's an entity that contains the shield, then here's the object for the shield. And you'll notice it's set for mesh standard material. You get access to all of the maps. It's got these maps baked in that have to do with the PBR material format. So we've got our roughness map, our metal map, normal map, a color map. And you'll notice these roughness and metal maps have a really weird look. That's because in GLTF it combines grayscale versions of a roughness, a metal, because the roughness and metal are supposed to be grayscale. It'll combine the AO map and the roughness and metal map into the RGB channels. So it's like AO is red, roughness is green, and metal is blue. And then you end up getting this kind of pinkish looking color. And it wants to just use one texture. It's kind of an optimization. The other thing to remember if you're going and manipulating things in here is that you want to make sure once you apply these maps that you crank up, the same as an A-frame, crank up the roughness and metalness amount to 1 so that it's using the full map the way it's supposed to be used. So you'll notice it's dark. If I want to add an environment map, in Three.js, I can just add anything. I can add, let me go back out to my textures. I can add the sky here and turn it on, toggle it. So now I get the full effect of the material. Okay, that's what it would look like with that reflection map. Now GLTF doesn't support environment maps yet. GLTF 2.0 doesn't, but one day it probably will. They're constantly adding to the spec. The other thing to know about this editor is that it should, I just filed a bug report this morning, but the roughness and metal map, you can actually make modifications in here, change these materials, and export GLTF and GLB. For some reason these won't export. There's a bug where it wants them to be the same image, and even though they are right now, if I go and export this, it won't see them as the same image and it won't export them. Or if I make a change to these, it won't see them as the same image, so I'll lose those on the objects. But like I'm just showing you this because at some point that'll get fixed, and this will be an excellent way of being able to go and build scenes for A-frame or Three.js and actually have access to all of the material properties, and then be able to export them using the GLTF format, and then use them export them and use them for Aframe in VR. So anyway, let's see what else. So I'm going to do another video soon where we talk about this map, this light map, and the AO map. These are two extra maps. So you have an AO map and A-frame, but the problem is that you have to have an extra set of UVs in order for these to work. So if I apply an AO map to this object right now, let's just make it a black and white. Let's do this grid, which should show up fairly well right here, and turn that on. It applies the map. Let's see if it did. But it doesn't actually show the map because there's not a second set of UVs, so it just made it dark. Okay? I don't know if you can see that. And the same thing with a light map. So an AO map is basically like taking a multiply filter with a texture and applying it to the object, so you can create like a shadow shape or shadows. And then the light map is if you want to bake lighting. We'll cover that in the next video. I don't want to go into it now, but these are two maps that aren't easily, and the same for this emissive map. You can make a light out of, or make an object seem to emit light using a mapping. But these aren't enabled in, well, AO map is, but you actually have to create the second set of UVs, but light map is not. And it's super useful to have this, because what you can do is, if you have repeatable textures in all of these, that tileable textures here, you can do, these aren't affected by tiling, the same tiling that these are, so you can create a second map using a second set of UVs and bake lighting on the object in order to have higher quality shadows or global illumination or something like that. So that's the Three.js editor. I suggest you check it out because it's pretty cool. Right now there's a couple of bugs. Hopefully they get fixed. And this is my server running from my bat file for my local development. Hopefully you liked the video and you found it useful. So let me just go back and show you what we covered one last time. Start the server up. Go into this blank cube cam. So we talked about rendering better environment maps, real-time environment maps, how the image quality or the settings, the size of the texture affects the way the roughness setup shows on the object. And then we also talked about GLTFs and then how to inject environment maps, because if you bring them into A-frame, they're just going to come in with this dark. You don't have, like GLTF currently doesn't support an environment map, so you have to have some way of actually putting the environment map on the object, and the only way to do that is to inject it. Hopefully eventually they'll just be able to ship an environment map with it, but even then you may still want to take like the Three.js cubecamera and be able to capture an environment map relative to where you put the object in a new scene, which is what we're doing here. So anyway, that's that. For the next video, I'll talk about baked lighting and the light map component that I've built. Hope you liked the video.